Hey everyone, my name is Rosika and welcome back to my channel Learn with Rosika. In the previous video, we learned the solution of question number 2 of exercise 1.1 of chapter 1, that is real number, of NCERT class 10 mathematics book. Today in this video, we will see question number 3, which is written in the board. The link for the previous video will be provided in the description box. Do like the video, and if you want to learn maths hassle-free, do not forget to subscribe my channel. Let's start. Here we have find the LCM and HCF of the following integers by applying prime factorization method. What we have to do is we have to apply prime factorization method to find LCM and HCF of these numbers. It is very simple. We have already done it in our previous videos. We will do it again to solve these three questions. Let us start. First of all, let me start with 12. 2 into 6 is 12. Again, 2 into 3 is 6. Another we have 15. 3 into 5 is 15. Another we have 21, which is 3 into 7 is 21. First of all, we will write the factors. That is 2 into 2 into 3 for 12. For 15, it is 3 into 5. And for 21, it is 3 into 7. Clearly, we can see over here, the common factor is 3. So, HCF is directly 3. And for LCM, we have the highest power of 2 is 2 square. The highest power of 3 is 3 to the power 1. And we have highest power of 5 and 7. So, here we get multiplication of these is 420, which is your answer. Moving on to the next question. We have 17, 23 and 20. Over here, as we can see, 17, 23 and 29. All of them are prime numbers. So, if they are prime numbers, then it is not divisible by any other number but itself. So, we will divide the same by the same numbers for each of them. Now for 17, it is 17 into 1. For 23, it is 23 into 1. And for 29, it is 29 into 1. We can see that the common factor is 1. So HCF equals to 1. And LCM would be the highest power of all the numbers. That is 17, 23 and 29, which will multiply and give us the number 11339, which is your answer. HCF is 1 and LCM is 11339. Next question. Here we have 8, 9 and 25. 2 into 4 is 8, 2 into 2 is 4, 3 into 3 is 9, 5 into 5 is 25. Here, as we can see, there is no common factor. We can move one step further to divide it with the same number so that we can get a common factor as 1. Here, we can write for 8, it is 2 into 2 into 2 into 1. For 9, it is 3 into 3 into 1. For 25, it is 5 into 5 into 1. Here, as we can see, again, HCF is 1 and LCM is highest power of 2, that is 1, 2, 3 over here, into highest power of 3, that is 1 and 2 over here, and highest power of 5, that is 2 again. Now, this will give us the answer 1800, which is your LCM. Here we completed question number 3. We will move to question number 4. Question number 4 is written in the board. It says, given that HCF of 306 and 657 is 9, if HCF of 306 and 657 is 9, then find LCM of the same numbers, that is 306 and 657. Now, in this case, we know a formula, HCF into LCM equals 306 into 657. Okay, this formula we have already done this in the previous video. We can apply this formula over here as we have HCF equals to 9, which is given in the question, and we need to find out LCM. Again, LCM equals to 306 into 657 divided by 9, which will give us the value 22338, which is your answer. Now over here we have question number 5. Check whether 6 to the power n can end with the digit 0 for any natural number n. First of all, let us understand what the question says. It says we have to check either if 6 to the power n, there is a number which is 6 to the power n, where is a natural number, and we know natural number means 1, 2, 3, 4 and so on till infinity. Okay, these are the natural numbers, all the integers after 0. So whenever we put the value of n as any of these natural numbers, we have to check if it ends with the 0, or the number we get if it ends with 0. This we can check by providing the value of n of the natural numbers. For example, if I give n equals to 1, it will give me 6. If I give n equals to 2, it will give me 6 into 6, which is 36. Again, if I give 6 cube, that is 6 into 6 into 6, which is again 216. Now, here we can see that if I multiply 6 any number of times, or if I put the value of n as any natural number, it will always end with 6. That is 6 into 1 is 6, 6 into 6 is 36, 6 into 6 into 6 is 216. From here we can assume that any multiple of 6 cannot end with 0. But this is something we have to write in exams, and we cannot solve it or we cannot prove it this way. So to prove in exams, what we have to do is, we know that a number, any number that ends with 0, for example 10, it is divisible by 5. Yes, 5 into 2 is 10. Let's say 100, is it divisible by 5? Yes, 20. 250, is it divisible by 5? Yes, with 50. So we can conclude over here that any number which ends with 0 must have or always has 5 as its one of the factors. Now let us take factors of 6. It is 2 into 3 into 1. That is, the factors of 6 are 2, 3 and 1, or we can add, or else we can write it in a different way, 3 and 1 and 6 itself. These are the factors of 6. So we don't see any 5 over here. So we can conclude, since 5 is not, okay, that is not visible in the board. Let me shift a little bit. Okay, since 5 is not of, is your answer. This is how you will prove in the exam, and not with this method. This is just to make you understand how 6 or any power of 6 ends. Okay, on which digit is it ends, and that is 6 every time. But it does not have 0. In any case, it will never have 0. So this is how you will prove, or this is the solution of question number 5. Let's move on to question number 6 now. Okay, so we have this question number 6, that is, explain why 7 into 11 into 13 plus 13 and this number are composite numbers. Over here, first we have to understand what are composite numbers. Composite numbers are the numbers which has, let me write it over here. Okay, composite numbers are the numbers which has other factors apart from 1 and itself. Basically, we can say that it is opposite of prime numbers. Composite numbers, for example 4, how many factors do 4 have? 2, 1 and 4. Apart from 1 and itself, there is another factor. For example, we have 6, that is 2, 3, 1 and 6. Apart from 1 and itself, it has 2 and 3 as its factors. So these are composite numbers. Now we have to check if these two numbers are composite numbers or not. Let us take the first number first. 13 here, since we have the addition in the middle and 13 on both sides, we can take it as common plus 1. Again we have 77 plus 1, which is equals to 13 into 78. Now here what we can do is we can factorize 78 as per the convenience and write it over here. 13 into 2 into 3 into 13. In this case, we don't have to calculate the exact whole number. We have already got over here 1, that is 13, 2, that is 2, and 3, that is third. First is 13, second is 2, and third is 3. We have already gotten 3 factors of the number apart from the number itself. What is the number itself? 13 into 78. This is factor number 1. 1. This is factor number 2. And we have factor number 3. 13, factor number 4, 2, and factor number 5, 3. So clearly this number has more factors than 1 and the number itself. So this is a composite number. Let's check with the second one. 5. Here we can take 5 as common, and in this case we can multiply all of it to get 1008 plus 1, which will give us 5 into 1009. Over here also what we can see is the number itself is 5 into 1009. First factor 5 into 1009. We have second factor, that is 1. We have third factor, that is 5. And we have fourth factor, that is 1009. So clearly there are 4 factors over here, which is more than 1 and the number itself, that is more than 2 factors. That means this is also a composite number. Over here we have completed till question number 6 of chapter exercise 1.1, and for question number 7 I'm not covering that in this video because in the book the type of question number 7 holds is only one that is provided, but I want to teach with some other questions which is of same kind, so I will cover that in the next video. So stay tuned and subscribe to my channel. Bye bye.